So also here, this is a pre-algebra lesson, shapes, anatomy. Anatomy means what we call the parts and pieces. So what's a shape? We could draw one, but we're going to define it. A shape is a closed, two-dimensional figure. And we will draw a large shape. There are many things that we could draw to represent a shape. This one is going to look like this, and it's not supposed to look like anything familiar. This isn't supposed to be a rectangle, a square, or rhombus, trapezoid, any special name. This is a generic shape. It does have 4 sides. Shapes can have 3 sides or many more. So this is a shape. It's closed. What do we mean by that? Well, I'm going to draw a very small figure over here that's not closed. This is an example of a figure that's not a shape because it's not closed. It's not closed because there's an openness to it. We have lines that are connected together, but it doesn't come back around to the original vertex. We could make this a shape by drawing an extra line between those two. Okay, anatomy. These points have a special name. We call this a vertex. More than one vertex is called vertices, or we say plural of vertex is vertices. Those are the points that the sides connect. So we want to point to one of these lines and call it a side. And a side is a line, technically a line segment because it has endpoints, a line that connects two adjacent vertices. So this is a side. It connects this vertex with this vertex over here. Why do we call them adjacent? Adjacent is a fancy word that means next to. These two vertices are next to each other. And so when you have a line that connects them, we call that a side of a shape. Is it possible to connect vertices that are not next to each other, that are not adjacent? Absolutely yes. These two vertices here cross the shape. These two vertices are not next to each other. They're not adjacent. We can connect them, but when we do, we're going to use a different kind of line. We're going to dot it because this dotted line is not a side of the shape. It's different. We call this a diagonal. And a diagonal is a line that connects to non-adjacent vertices, points that are not next to each other. The word diagonal is a common word. People use it. This is the proper definition of what a diagonal line is. A diagonal line is a line that connects two non-adjacent vertices in a shape. Very often people call diagonal lines Lines that are neither vertical, straight up and down, or horizontal, it's like across, like the horizon. People tend to call lines that are neither vertical or horizontal diagonal, but that is not correct. A line that is neither vertical or horizontal is properly called oblique, and a diagonal line is exactly what we've put on our paper. Shapes have area. An area as a concept is the space that fills a two-dimensional surface. And we have the concept of perimeter. Area and perimeter are measurements. They're not an anatomy of the shape, but they're often measurements that we care about when we apply our math. The perimeter is the distance around the shape. Which is the same thing as the sum of all the sides. Many shapes have formulas for calculating area and perimeter. Sometimes we need pretty sophisticated techniques in order to find area and perimeter. But it is a common thing to want to measure when we use shapes in the real world for design, architecture, and art.